All right, we're back. We're on page 108 of Notes 10 of Math Analysis, doing the law of sines, solving oblique triangles. Those are non-right triangles. And we just dealt with the scenario where we're given the ambiguous case, so an acute angle, that means you have an angle, side opposite the angle, other given side, right? So we just dealt with the case where the side opposite the angle was bigger than the other given side. That's one triangle, use the law of sines, you're done. If the side opposite is not bigger than the other side. So you already checked that. You already know there's not just one triangle, because if it was bigger, there'd be one triangle, you'd be done. So you know that's not the case. Now you have to calculate something. So if you look at these three scenarios, here we have no triangles. Here we have exactly one right triangle, which in my experience will never happen, but maybe it will, who knows? And then here, two potential triangles. So the two potential, hard to say, potential triangles are here, right? The first place you connect, or the obtuse triangle here, right? Two potential triangles. But in all cases, what we really need to know is the height, right? So if we knew the height, because here the side opposite is less than the height, no triangles. Here the side opposite is equal to the height, one right triangle, which will never happen. And here the side opposite is bigger than the height, and we already knew it was less than the other given side. When that inequality exists, height, side opposite, other given side, two triangles. That's your two triangle case. But in all cases, we need to know the height. So I'm actually going to go back to the previous page because it has a bigger picture of the triangle. We need to calculate the height of the would-be right triangle. So the would-be right triangle is here. And so this is our height. And we're going to calculate the height in the exact same way every single time. So if you look at what we know an angle. We want the side opposite the angle, and we know the hypotenuse of this right triangle. So it seems like the sine of the angle is the height over the other given side. So the sine of the angle is the height over the other given side, which means the height is going to be the sine of the angle times the other given side. So I'm going to say height is, and I'm going to write it just like that. I'm going to say it's other times sine of the angle. So we're always going to use that. And that actually, in my experience, is going to be very useful. I use that concept, like I look at this scenario in, we do some stuff in Calc 3 with like vectors, I guess. You may not even know what a vector is yet, but we do some stuff with vectors, and when we have to find some angles, I'm always like, oh, it's like the ambiguous case. Like the height is equal to other times the sine of the angle. And you just kind of like know it. So it's useful to always know that fact. So we're going to calculate the height. It's always the other side times the sine of the angle. And then the relationship of the height to the opposite side, the side opposite the given angle, is going to tell you an awful lot. So let's see what these three things are saying. If the side opposite the given angle is shorter than the height, side opposite is shorter than the height, you have this, then you get, I'm going to say 0 triangles, because you never connect with the horizontal. Like it's never going to happen. So if we like have a physical class, like face to face, I will tell you a story about swinging a bucket at someone's head, but I'm not going to do that in the videos. But in this particular case, the bucket never connects with the person's head. But you know, so some things have been lost in the switch to virtual learning. So if the side opposite is equal to the height, is exactly equal to the height, like how is that going to happen, right? The side opposite, the height is equal to the sine of the angle times the other given side. Sines tend not to be rational, which means that the height tends to be an irrational number. How is it going to exactly equal the side opposite? I do not know. That just means you didn't notice something. But anyway, you get one triangle. Because I'm going to say it's a right triangle. It's actually a miracle, because that's not going to happen. But you never know. A miracle has occurred. That won't happen, I don't think. But, you know, who knows? And then finally, if the Side opposite the given angle is greater than the height, right? We already know that the side opposite is less than the other given side, because if it was greater than the other given side, there'd be one triangle and we'd be done. We never would have found the height, but we know that it's less than the other given side. So side opposite is less than the other side. It's greater than the height. That gives you two triangles. If I'm telling you a story about buckets, you have two chances to hit the person in the head with the bucket. Whoa, where are you? So I'm going to say two triangles, because I'm just going to say the swinging side, and go back to the GeoGebra sketch if you want to see it happen again, right? The swinging side intersects the horizontal twice. I guess it's twice on the same side as the angle, but like whatever. I'm not gonna bother saying that here. So we get twice. And then here's like, it's a decision tree, or like sort of a, kind of like some pseudo code if you're gonna try to like write a program that does this. So if the opposite is greater than or equal to the other, you get one triangle, so you solve it, and you're done. Otherwise, you move on, right? So if this is not the case, if the opposite is less than the height, so you have to calculate the height, which is the other side times the sine of the angle. You calculate the height. If the opposite is less than the height, there are no triangles and you're done. Otherwise, you move on to the next scenario. The opposite is greater than the height, which actually has to be true. It's like the default, right? If you got through here, this must be what's happening. So if the opposite is greater than the height, you have two triangles, you start solving, and it's a process, and we'll do that in the next video. Otherwise, you have a right triangle, and that's just insane. So you kind of have to keep track of everything, think it through a lot, like imagine, or like literally just like swing your pencil back and forth and think like, will it connect? Will it not connect? Will it connect twice? How many times can these things happen? But anyway, I'm gonna end this video here. I'll be back in the next video. Probably actually do the ambiguous, well, these are all the ambiguous cases. I personally also, I always say like, people always think the two triangle thing is the ambiguous case. I also think of it that way. But really it's angle side side is the ambiguous case. Anyway, be back in the next video, probably do the two triangle case, and hope to see you there.